So the beta cutoff frequency f beta, some books they also refer it by term FHFE. So you should, by now you should be clear that beta and HFE are one and the same. Only the notations are going to be different. Otherwise, the DC current gain significance is going to be the same. So this is going to be the short circuit signal forward current ratio cutoff frequency. So it is called as CE short circuit small signal forward current transfer ratio cutoff frequency. So it is called as f beta. So f beta is the frequency at which the transistor's gain drops from 3 dB from mid frequency value. So when you put f is equal to f beta here, you get minus HFE. Okay, when you put f is equal to f beta in the given expression, you will get minus HFE by 1 plus j. Okay, minus HFE by 1 plus j. And when you take the modulus for the complex number, you get minus HFE by root 2. And HFE by root 2 is equivalent to, we have seen the how to find the bandwidth, right? So HFE by root 2 is going to be 50% of the power. So this f beta is the frequency at which current, the forward current gain drops by 50%. Or if you say in dB, it drops by 3 dB. From the maximum value, the current gain drops by 3 dB from the constant value in the mid frequency region. So f beta will represent the maximum attainable bandwidth for a given current gain, because we are finding f beta by short circuiting the load, correct? So this is the maximum. This frequency corresponds to the maximum attainable bandwidth. So after once you find the value of f beta, you can conclude that you cannot attain any bandwidth for your CE amplifier more than the value of f beta. So that has to be understood very, very clear. That is the significance of beta cutoff